Hello, folks. So, in this video, I wanted to talk about horizontal scaling and vertical scaling, right? This is a popular term that is used in the concept of scaling. And let's actually try to understand how you can actually remember the nomenclature or the terminology and what it means, right? So, let's get started. So, let me use a whiteboard. Usually in the world of scaling, right? Excuse me. So, usually in the world of scaling, people try to basically scale their resources. What do you mean when you say resources, right? I usually remember it as the acronym or the mnemonic. I think they call it as mnemonic okay, acronym CNS, right? So when I think of computation, I think, and when I think about computers and resources, I think about CNS. So that is basically compute, right? Network, storage, right? And usually for compute, I think of CPU and RAM. Though you can actually consider RAM as part of storage because RAM is used to store things, but basically that stored stuff is used only by the CPU for fast access. So I'm just putting it together, CPU and RAM. And then network is basically your internet, intranet, and whatnot. Usually the internet, but also the private network, right? Internet is the public network. Yeah, I'll probably talk about network stuff in a separate video. Storage is generally the disk storage, and then you might have other storage systems like distributed file systems, DFS, distributed file systems. And then stuff like network attached storage, storage attached network, and whatnot. Systems, and then network attached. I don't know what these are though. Network attached storage or storage. It's called SAN as storage attached network, right? But basically any storage solution, right? So that's the CNS part. CNS. Whenever you think about resources, you think about compute network storage, and these are these, like CPU, RAM, and the internet, private network, and all that. And then storage, disk usually, and distributed file systems or object storage. There's also object storage, right? Like for example, S3 buckets and stuff like that. AWS S3 bucket and whatnot, or blob storage, right? Blob or object storage, right? Let me write that in a better manner. Object storage. Cool. So that is that, right? Now, so when people talk about scaling, they talk about scaling resources, and the resources are basically usually in the world of computation, it's CPU and RAM, right? Usually they're trying to scale this because disks, it's not so hard, but it can be hard if you're actually going to store a lot of data. For example, you're creating a system for object storage or blob storage or stuff like that, right? Let's take one of the examples, for example, compute with CPU and RAM, and look at how you can actually scale your CPU and RAM resource, right? I'm not going to talk about other resources. I'm going to mostly talk about CPU and RAM resource over here. And how do people scale CPU and RAM, right? Especially in the cloud or like the private cloud or the public cloud and all, right? So, when people say scaling, they mean scaling resources, and in this case, I'm specifically taking up, you know, I'm taking up compute, the CPU and RAM. So, how can you scale, right? For example, if you have a private cloud or public cloud or whatever, and let's say you have physical machines, or you basically call them as or nodes, right? Basically bare metal, right? Or you have virtual machines, right? Inside the physical machines or the bare metal, and you're working with virtual machines mostly, let's say, or nodes, right? A node is basically just a computer. So you want to scale this. Now, how do you scale this, right? So there are two methods popularly known as vertical scaling, right? Vertical scaling and horizontal scaling. I'm not sure how they came up with this naming. I'll probably research more and talk about it, but I'll tell you how I remember it and understand it, right? So I think it probably relates to some real world scenario, and how I guessed it was like this, right? So let's say you want more CPU and RAM, right? Usually, when you have a real world server, I'm not sure, like in real world servers, you basically have a motherboard which has your processor, your CPU, and the RAM. I've actually seen RAM as like slots. You usually have slots into which you basically plug your RAM, right? You can actually expand and increase your RAM by plugging into the slots, or using different RAM cards and just put them in the slots. And there is a CPU, and this is like the motherboard and all, right? Whenever you want to basically scale, right, you basically either what you can do is, this is like one, let's say one physical machine, or let's say you have one VM, right? Now, what do you do to scale it? Either one thing that you can do is, let's say this is VM1, right? This is just VM1, um, or let's say VMA. Let's say this has 2 cores CPU, right, and 2 GB RAM, right? Now you want to increase this, scale this up, because the application running in this VM needs 4 cores and 4 GB of RAM. Now what do? Either you can actually upscale, like increase the resources for this VM. Since it's a virtual machine, you can actually change the type of the virtual machine, right? Interesting that I could draw with my hand itself. So you can actually change the size or the type of the virtual machine, and for example, shut it down, and or something like that, and maybe have another instance, so that you don't have any downtime when this machine is killed. VMB, which also has 2 cores and 2 GB of RAM, right? For example, or what you can do, you can create VMB, and you can create 4 cores and 4 GB of RAM over here, and then just you can create probably another VM and have 4 cores and 4 GB of RAM, and then kill this application, and have all the traffic go here first, and then kill this application. You can kill this VM, right? You can do that. So that's one way, basically, moving from VMA to VMB and then killing VMA, right? So this way, what you have done is, you have actually taken your box. Usually people call your VMs as boxes or nodes and all, right? So you take your box and you basically scaled it by increasing the size of the box, right? though in this case it was a separate box. Or what you can do is, I don't know if cloud services allow online scaling of their virtual machines, wherein you take VMA and without restarting the VM, you can actually change it from 2 GB and 2 cores to 4 GB and 4 cores without any downtime. I'm not sure if you can do that. If you can do that, great, right? So you basically have a small box and you made it a bigger box. I visualize it like this. And this way I call it as like vertical scaling, because in terms of height, right, it became bigger. Right? So let's say it was like this, right? Now it became 2 times bigger. Like it was like now, if it was 1x, now it became 2x. And it increased its height vertically, right? So you call this vertical scaling, where you increase the resources of the existing box, right? Or VM, one moment. Box or VM or node, right? Whatever it is, it can be a physical machine, it can be a virtual machine, and whatnot. Now, you can also do another thing, right? You can do something called horizontal scaling. In vertical scaling, you basically increase the resources of the existing node. In horizontal scaling, what you do is, let's say this is your box and it has 2 cores and 2 GB RAM, right? Let me just write it out as RAM so that it's clear it's not some disk storage or whatever. Right? Now I can, let's say this is box A. Now what I can do is I can add one more box of the same size or bigger size also. Mostly same size is what people do. I think bigger size, I don't know if it makes sense. So now you put 2 cores, 2 GB RAM. Now you totally have 4 cores, 4 GB RAM, right? And here you can see the height of the box remains the same. It's kind of to say that you didn't change the size of the box, right? And here we just called it as like increasing the height of the box. You can also increase the width of the box, right? But anyways, you just think of it like increasing the height of the box and call it vertical scaling, where you vertically scale by increasing the resources of the same machine. When you add more machines, it's called horizontal scaling, where you just add more machines in a line, right? You can also probably stack it up. If it's a cloud, it's a data center, you can stack up your servers and say, I put this box on top of this, then why can I call it vertical scaling? Well, anyways, but horizontal scaling is all about adding extra boxes. Vertical scaling is increasing the size of the existing box by increasing the resources of the existing box, the cores, the RAM in this case for the compute. And in horizontal scaling, you just add more boxes, right? Add more instances. So this becomes 6 cores and 6 GB of RAM. One thing to note over here is your application has to support this, wherein your application can run in multiple instances. Your app will run 3 instances, in this case app A, app this can be called as app 1, app 1, again this is also app 1, but another instance of app 1, and then app 1, right? Let's say it needs some storage, for example some database, it should all connect to the same database. The problem is database will become the bottleneck, but other than that, they will all share the same brain, right? Memory to store the data. And the traffic that comes in, you should have a load balancer. So these are all stuff that you need to take care of when you do horizontal scaling, right? Load balancer, or like something that actually load balances the traffic from outside. Let's say the traffic is coming from here. It gives, let's say, equal amount of traffic to these, or round robin. First request goes here, second request, third request, and then fourth request goes here. Or some sort of like weighted. For example, if this has more cores, let's say 8 cores, 8 GB of RAM, then this is more weight. So more requests go here and stuff like that. Anyways, so I think you can do stuff like that. You need to have a load balancer. In this case, you just increase the size of the VM. Your app doesn't have to actually be aware of anything that it will be horizontally scaled and whatnot, or stuff like that, and it doesn't have to be written in a very specific way. It just is given more resources. The problem with vertical scaling is that usually your physical machines can only go up to so much resources for CPU and RAM, right? After that, you can't increase the CPU and RAM, I think, at some point. Usually, especially if you're using cloud services, there is some limit to how much you can increase. Also, the other problem with horizontal scaling is it's a very single point of failure, right? In vertical scaling, basically, you don't have this limit. Instead, you can actually put more and more cores and easily just add more and more machines. There is no limit to how many machines you can add, but usually there is a limit to how much CPUs and RAM you can have for a given machine in cloud services, right? Though I think in a physical machine, I don't know, you can probably keep adding more slots and whatnot. But I think somewhere there must be some limitation, and also the other limitation being when you just vertically scale, there's a single point of failure. This one machine dies, the whole system goes down. Here, if one machine dies, you still have 2 other machines, right? So that's one good advantage about horizontal scaling. But your app has to be written in such a way that it can be horizontally scaled, right? And this can work in a manner that it is not aware of the other instances, but it doesn't affect other instances because the DB is common. So yeah, there are cases where you can horizontally scale, and the applications run in a cluster mode. They are aware, right? They're cluster aware. They're aware of the other instances and all that. Aware of other instances, right? And they horizontally scale. They do sharding and whatnot. For example, if it's a database itself, like Redis and whatnot. So yeah, that is horizontal scaling, where you horizontally place your boxes. That's how you remember it and whatnot. And the benefits I told you. And in vertical scaling, you basically just increase the height and increase the resources of that single machine, existing machine. Think of it like this, vertically increasing the height. Here, think of it like placing your servers side by side in a horizontal manner. That's all I had for this video, talking about vertical and horizontal scaling. I'll see you in the next one. Bye bye.